In this video, we are going to discuss the concepts of arithmetic progressions. Here are the concepts. We'll start by understanding what is arithmetic progression and understand what are the different terms that are related to arithmetic progression. We'll see the nth term formula, which is called AM of an arithmetic progression, how to derive the formula for calculating the nth term. Then we will see the sum of the first n terms formula, followed by a special case of the sum of the first n terms, which is sum of the first n positive integers. So what is arithmetic progression? It is a list of numbers or pattern of numbers. This chapter is all about numbers. So arithmetic progression is a list of numbers or pattern of numbers in which each term is obtained by adding a constant number to the preceding term, except the first term. So let's see a few examples to understand more. So here are the examples of arithmetic progressions. In this example, each number in the list or pattern of numbers is called term of that arithmetic progression. So 1 is a term, 2 is a term, 3 is a term, 4 is a term, and so on, nth term. And in this example, 100 is a term, 70 is a term, 40 is a term, 10 is a term, and so on up to n terms. And here are the other examples. So each number is a term of that arithmetic progression. Of course, 1 is the first term in this example, 100 is the first term in this example, and -3, 3, and -1 are the first terms in these respective examples. Now, let's see what is the constant number which we have to add to the preceding term to get the next terms. So, in this example, 1 is the first term, and by adding 1 to 1, we get 2, which is the next term. And by adding 1 to 2, we get the third term, which is 3 here. So each term is built by adding 1 to the preceding term. Here in this example, 100 is the first term. And by adding -30, we get 100 minus 30, 70, which is the second term. So by adding -30 to 100, which is the first term, we are getting the second term, 70. And by adding -30 to 70, we are getting 40, which is the third term. So each number, except the first term, of course, each number in the arithmetic progression is obtained by adding -30 to the number preceding to the 1. And here are the other examples. There are specific names and symbols given for each of the term and constant number of the arithmetic progressions. So let's pick up the same examples to understand what are those specific names and symbols. Here are the arithmetic progressions. So 1, 100, -3, 3, and -1 are the first terms of the respective arithmetic progressions. And these first terms is indicated with symbol A or A1. Usually we indicate the first terms with A, though A1 is also a right way of indicating the first term, but in general, the first terms are indicated with symbol A. And the second, third, fourth terms are respectively A2, A3, A4, and so on. And the nth number of the arithmetic progression is called nth term, and it is indicated with symbol AN. And the constant number which we add to the preceding number to get the next number is called common difference, indicated with symbol D. So as we have discussed, except the first number, the rest of the terms are obtained by adding the common difference or the constant number to the preceding number. So as we discussed, 2 is the second term of this arithmetic progression, and it is obtained by adding 1 to the preceding number, which is 1 here. So 1 plus 1, 2, and 2 plus 1, 3, and 3 plus 1, so on. Similarly, 100 minus 30, which is the constant number or the common difference t for this arithmetic progression. So 100 minus 30 is 70, and 70 minus 30 is 40, and so on for the rest of the examples as well. So the key thing to notice here is that between any two successive terms, the difference would be d. And the d is plus 1 for this arithmetic progression, and the d is minus 30 for this arithmetic progression, and so on. So if you take 10 minus 40, it would be minus 30. 40 minus 70 is also minus 30. So between any two successive terms, the difference would be d, and these are the common differences are d for the respective arithmetic progressions. Couple of important points. The first term or any term like A2, A3, A4 up to AN, and also the common difference, they can be positive, negative, zero, or fractions, decimals, including irrational numbers. Simply, they can be any of the real numbers. But n, which indicates the slot or the position of the number within the arithmetic progression, that n must be a positive integer. Let us see the reason why n must be a positive integer. As we have discussed, the first term of the arithmetic progression is indicated with A or A1 to indicate that it is the first position within the arithmetic progression. Similarly, second term is in second position, which is indicated by A2. So here our n is 1 for the first position, for the first term, and for the second term, second position, n is 2. Third term, third position, n is 3. And for the fourth term or fourth position, n is 4. And for the nth term or nth position, n is n. So our count or the positions starts from 1 in arithmetic progressions. There is no zeroth term. And obviously there is no negative 1th term or negative 2th term and so on. Because our positions or index starts from position 1 followed by position 2, 3, 4, and so on. So n has to be a positive integer. It cannot be 0, and it cannot be negative numbers as well. This is an important point to remember when we come across the questions like where we are asked that a particular number is a part of the arithmetic progression or not. So after calculating, if n comes up as a positive integer, then yes, that number would be a part of the arithmetic progression. If not, if n comes up across as 0 or a negative number or a fraction or decimal, then that number won't be part of the arithmetic progression. So let's keep these points in mind. So in short, n indicates the number of terms in an arithmetic progression. So it has to be a positive integer. Now let us see the general form of an arithmetic progression. There are two types of arithmetic progressions. One is finite progression. What it means is that the list of numbers ends somewhere. So we surely have a last term when it comes to finite arithmetic progressions. So here in this example, the terms are A1, A2, A3, A4, and A5, and A5 being the last term. And it is indicated with symbol L for finite arithmetic progressions. And arithmetic progressions can also be infinite. That means that the list of numbers never end. They keep going on, and there is no last term L for this infinite arithmetic progressions. Now let us see the nth term of an arithmetic progression. How to calculate, or what is the formula for nth term. So let us list out the terms. First term, second term, third term, fourth term, and so on up to nth term. As we discussed, the symbol for the nth term is an. And sometimes it is also indicated with symbol L to indicate that it is the last number of the arithmetic progression. L for last number. So let us say our first term in the arithmetic progression is A, and the common difference constant number is D. Then the terms of the arithmetic progression would be A plus D, A plus D plus D, and so on. So as we discussed, except the first term, the remaining terms of the arithmetic progression are obtained by adding the common difference D to the previous term or the preceding term. So here the preceding term for the second term is the first term A, and the constant difference is D. So by adding A to D, we get A plus D for the second term. And adding D to A plus D, we get A plus D as the third term, and so on. Simplifying that, we can write the terms of the arithmetic progressions as A plus D, A plus 2D, D plus D, 2D. And similarly here, the fourth term would be A plus 3D, A plus D plus D plus D, 3D, A plus 3D, and so on. And if we rearrange the terms like this, in this example, D can be written as 2 minus 1D. 2 minus 1 is 1 anyway. 1 into D, D. Similarly, here 2D can be indicated as 3 minus 1, D. 3 minus 1 is 2, 2D. And so on. So as we can see, the second term is indicated as A plus 2 minus 1D. And the third term is indicated as A plus 3 minus 1D. And the fourth term is indicated as A plus 4 minus 1D. And on the similar lines, we can write the nth term as A plus n minus 1D. And this is the formula for calculating the nth term of the arithmetic progression. So the nth term an of an arithmetic progression with first term A and common difference D is given as an is equal to A plus n minus 1 D. Now let us see the formula for calculating the sum of first n terms of an arithmetic progression. Let's say these are the terms of our arithmetic progression. A plus D, A plus 2D, A plus 3D, and so on up to A plus n minus 1D, which is our nth term. And we know this formula, and we have seen this just a few moments ago. So the sum of the first n terms, S, is nothing but the addition of all these individual terms. A plus D, A plus 2D, and so on up to plus A plus n minus 1 into D. There is a reason why there is a gap indicated here. Let's see why. The same sum can be written as in the reverse order also. Here we have written from the first term to last term, and here we have written last term to first term using the commutative property of numbers, and it works for addition. Commutative property works for addition of the numbers. So the sum can also be written from last term to first term, that is nth term to first term. Now let's add these two expressions. So s plus s would be 2s, and let's add each term now. So adding the first term here to the first term here, we get a plus a, 2a, and plus n minus 1d as it is. Now adding second term to second term, we get a plus a, 2a, and if we add n minus 2d to d, we get n minus 1d. If we expand and simplify, we get n minus 2d plus d as n minus 1d. Similarly, adding third term to third term, we get a plus a, 2a, and if we add n minus 3d to 2d, we get n minus 1d, and so on. Now adding the last term to last term, rather nth term to nth term, a plus a, 2a, and n minus 1d as it is. As we can see, it is the same term repeating. 2a plus n minus 1d plus 2a plus n minus 1d plus 2a plus n minus 1d and 2a plus n minus 1d, and it is repeating n times. So if you add the same number n times, we can get 2s as n into 2a plus n minus 1d, because this term is repeating n times here. So we can write 2s as n into 2a plus n minus 1d. Now sending 2 to the right hand side, we get the sum of the first n terms of an AP as n by 2 into 2a plus n minus 1d. And there are two more formulas that can be derived from the main formula. S is equal to n by 2 into 2a plus n minus 1d. Let's see how. So here 2a can be written as a plus a. 2a can be written as a plus a. And we know that a plus n minus 1d is an, which is the nth term formula. So the main formula can now be simplified into n by 2 into a plus an. And if the arithmetic progression is to be a finite one, an is indicated as the last term. The finite arithmetic progression will have last term. So we can also write the same expression as n by 2 into a plus l, l for the last term. So this is the formula or formulas for calculating the sum of the first n terms of an arithmetic progression. Let us keep in mind all the three formulas, which are useful depending on the problem or question given. Sometimes the question may indicate n, a, and d, and we can use this formula to calculate the sum of the first n terms. And sometimes they may simply indicate n and the first term and the nth term, then we can use this formula. Or sometimes they can indicate the n, the first term a and the last term, then we can use this formula. So depending on the question given, we can use one of these formulas to calculate the sum of the first n terms. Now let's take a relook at the nth term formula for arithmetic progressions. We already know that the nth term of an arithmetic progression can be calculated using this formula, a plus n minus 1 d, where a is the first term, d is the common difference, and n indicates the position of the number in the list of numbers of the arithmetic progression. There is one more formula for calculating the nth term, an. It is given as the difference of the sum of the first n terms and the sum of the first n minus 1 terms of an arithmetic progression. So an, the nth term, can also be calculated as sum of the first n terms minus sum of n minus 1 terms of arithmetic progression. So there are two formulas to calculate the nth term of an arithmetic progression. So depending on the question that is given to us, we can use either of them, whichever suits. Now let us see how we can derive the new nth term formula based on the sums of arithmetic progression. So the sum of first n terms would be the sum of all the terms starting from the first term to an minus 1 plus an. And what is the sum of first n minus 1 terms? It would be the sum of all the terms starting from first term up to an minus 1. So if we subtract Sn minus 1 from Sn, Sn would be all the terms up to an, and Sn minus 1 would be all the terms up to an minus 1. And because we are subtracting, the signs of the terms will change. Positive a1 will become negative a1, positive a2 will become negative a2, positive a3 will become negative a3, and so on. And positive an minus 1 will become negative an minus 1. So as you can see, positive a1 will cut negative a1, positive a2 will cut negative a2, positive a3 will cut negative a3, and so on. And positive an minus 1 will cut negative an minus 1. And what remains is an. And that's what we get. Sn minus Sn minus 1 is equal to an. And this is the formula which we discussed just a while ago. So we derived the new nth term formula based on the sums using simple subtraction method, subtracting Sn minus 1 from Sn. We can also use the sum of the first n terms formula, which we saw just a while ago. So Sn is equal to n by 2, 2a plus n minus 1d, and Sn minus 1 would be substituting n minus 1 in the place of n. So it would become Sn minus 1 by 2 and 2a plus n minus 2d. Why n minus 2d? Because we have to place n minus 1 in the place of n. So n minus 1 will become n minus 2d. Now if we expand both the sums and then subtract, we get the same result. Sn minus Sn minus 1 is equal to an. Please give it a try using this method also. Now let us see the sum of first n positive integers, which is a special case of sum of first n terms of an arithmetic progression. So let's take n positive integers. first n positive integers starting from 1, and they would be 1, 2, 3, 4 up to n. So the number of terms is n here. And the sum of the first n positive integers, Sn, would be addition of all these n numbers, 1 plus 2 plus 3 up to n. Here in this progression, our first term a is 1. The common difference d is also 1. So as we can see, 4 minus 3 is 1, 3 minus 2 is 1, and 2 minus 1 is also 1. So the common difference d is 1. And the number of terms is n anyway, because we are taking first n positive integers. Here an, the nth term, would also be n. It may be slightly confusing, but let's try to understand with an example. Let's take n as 50. That means that we are taking first 50 positive integers. So the numbers would be 1, 2, 3, 4 up to n, which is 50 here. So the nth term is also n only. So an is also n, because we are starting from 1 and d is also 1. So our progression would be 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, and so on up to 50. So an will also be 50 in that case. So in general, if we take n positive integers, the number of terms would be n anyway, and the nth term an will also be n here in this special case. So here is our formula, which we saw just a while ago, for the sum of the first n terms of an arithmetic progression. This is S is equal to n by 2 into a plus an. So n is number of terms, n is n anyway, a is 1, and an is also n. So let's substitute these values into this formula, and we get n by 2 into 1 plus n, because a is 1 and an is n. And this can be simplified into S is equal to n into n plus 1 by 2. And even if we substitute these values in the other two formulas for the sum of the first n terms, we should get the same result. And that completes the theory and concepts part of arithmetic progressions. Hope this video is helpful in clearing up the concepts for you, and hope your time is well spent and productive. If you find this video helpful, drop a comment with any questions, suggestions, or just let me know which part clicked for you. Thanks for watching, and I'll see you in the next video.